This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
My name is Oskar, and I want to talk to you about prompt compressor today. Previously, I used to talk about Porter. It was this little project to port your JS to TypeScript. But people from this audience told me, why don't you port your TypeScript back into JS, because it makes more sense. It was during ChatGPT 3 days. So during that time, I also developed another thing. Basically, it was calling GPT in a loop and trying to force it to make this thing that I really wanted. It was basically kind of agent kind of thing. So there are two kind of people, right? Some people try to desperately keep AI inside the box, so it won't do naughty stuff. So there are other people trying to give it all SSH keys, all their secrets, all their password, and put it into the world and tell it, get out of the box, right? So I was the latter. So I wanted to see how far can it go with all my access to my to account on cloud on GCP. But it was ChatGPT, if you remember, ChatGPT 3, if you remember. So limitations were pretty harsh. It was like 2048 tokens. It ain't much. I tried to work with that. I wanted to run commands, and often when you see outputs of certain commands, they're not really that dense in terms of information. Sometimes you can just remove entire parts of text and it still works. It still makes sense. So removing random tokens works pretty well. Oh my God. I don't know what happened. So it's very simple idea. Just remove random tokens from the prompt. It will make your information denser, and you can actually read this sentence, right, with some letters missing. So LLM can do that too. So it's kind of crazy idea, but it's also kind of works. One of colleagues from my office told me, why don't you benchmark it? If it makes sense, it should produce some numbers, right? So it did. I have no idea why these charts. I didn't investigate them too deep, but it actually seems kind of makes sense. But why it's better when you remove 10% of tokens? Maybe there are people that understand science and stuff. Then please help me to understand this. Here, if you remove 20% of tokens in this benchmark, it's even better than with all the tokens. I know. I made it into kind of Docker container to make it invisible proxy. So this is a prompt compressor. You can just plug it into your existing LLM stack and it will work. So this is kind of how it works. You send the prompt compressor just do the compression, send it to OpenAI or whatever, and you get response. So basically, it's a GitHub project. You can contribute if you will. You can use it. I won't steal your OpenAI key because it's secret. That's it. If you want to contact me, please feel free to reach out. Where's the host? Okay, so I will just, maybe there are some questions.
Okay, I have one question. Because on the slide you demonstrated deleting tokens, like removing some letters, but tokens usually do not contain the specific letters, or but more usually the whole phrases or something. So does removing specific letters really lowers the number of tokens that we use? Because for example, there can be a token UR, and when you remove this O and those A and the E or whatever, then it divides into two tokens, which are understandable.
Yep, that's a very good question, and actually that was for like demonstration purposes. But actually, that's very right. That tokens are like parts of words, like couple of letters, and they're like there's corpus of tokens for particular LLM, right? So removing letters like wouldn't necessarily lower the number of tokens. But actually, in actual implementation, I tokenize the input and then remove tokens, not just letters, but entire tokens from input. So it was just for demo purposes, but in actual like code, it's removing tokens, not letters.
Okay, thanks.
So I was wondering, so do you have like any approach or algorithm that you use when determining which tokens to remove? Like are there some like redundant protocol info or something, or it's just random tokens?
Yeah, this is also a good question. I also tried to put some thought into this, but actually for like in this version, maybe it's future improvement. But actually we could do much better than removing just random tokens. We could maybe also use like lemmatization to just shorten the words, and LLM can like eat them also like very well and make sense of that. So that would be another approach, yeah.
Okay, so it's like trying to compress them. Yeah, it's compressor, like retain the sense of the tokens, and but without additional info.
Yeah, exactly. And also the trick is to make it in like lightweight way, right? So we don't want to have another LLM call to compress the message, but it should be something very simple to not put like heavy load or additional costs. Yeah.
Okay, thank you.
Thank you.
All right. And with that in mind, we thank you for your valuable contribution.
Warsaw.